The 14% logic decay. Most large language models lose 14% of their existing reasoning capabilities for every 100 gigabytes of new fine-tuning data. This decay, known as catastrophic forgetting, occurs because gradient descent updates weights globally, often overwriting stable logic circuits to accommodate new token patterns. Stanford's June 2026 report on dormancy training suggests we can stop this by simulating biological sleep cycles during the training process. Mechanism of homeostatic scaling. Dormancy training introduces a mechanism called homeostatic scaling, where the model enters a low-power weight rebalancing phase. Instead of active inference, the system identifies noisy weights that lack reinforcement and pulls them back toward a baseline mean, effectively shielding the base model knowledge core from being overwritten. This is not just a fine-tuning trick. It is a fundamental method for managing weight drift during continuous learning, and the metabolic consequences are stranger. The 9% compute tax. The catch is a significant compute tax. Stanford's benchmarks show a 9% increase in total training time to accommodate these consolidation cycles. Furthermore, on the MMLU Pro benchmark, dormancy-trained models actually underperform standard models during the first 48 hours of training. The retention benefits only become visible after the third cycle of consolidation, which means this technique is poorly suited for short-run experiments. This trade-off between immediate performance and long-term stability changes how we calculate training ROI. The signal under the noise. The shift toward dormancy cycles indicates that we are moving away from static snapshots and toward metabolic architectures. By combining the homeostatic scaling of the weights with the 9% training overhead, it becomes clear that model longevity is now a hardware-software co-design problem. For builders, this means the metric of success is no longer just how fast a model learns, but how much of that learning it can retain after 6 months of continuous fine-tuning. If a model cannot consolidate its own weights, it is effectively a disposable asset that will eventually fail in production. Watch for the integration of these consolidation tensors into the Llama 4 training architecture later this year as the first real test of this at scale. Subscribe for more.